Good morning, students. This lesson is of class 10th for the subject of physics, topic electromotive force, terminal voltage, and internal resistance of a cell and combination of resistors, which is covered in chapter 8, that is current electricity, and this particular topic is on page number 188 of your textbook titled Concise Physics by Selena Publications and is being submitted to you on 17th November 2020. All students may now open page number 188 in front of you. Our first topic for today is electromotive force or EMF of a cell, which is written as epsilon, and the symbol of epsilon is drawn in the notes provided to you on 17th November 2020. Students, EMF is defined as the energy spent or work done. So it is defined as energy spent per unit charge in taking a positive test charge around the complete circuit of the cell. Now, students, by complete circuit of the cell, we mean that in the circuit outside the cell as well as in the electrolyte inside the cell. So, students, it means that when no current is drawn from a cell, that is, when the cell is in open circuit, the potential difference between the terminals of the cell is called EMF. Thus, EMF can be mathematically given as ratio of work done to the test charge. That is, epsilon is equal to W, that is work done, divided by Q, that is charge. Now, students, EMF of a cell is its characteristic property and is different for different kinds of cells. It depends on the material of the electrodes, that is cathode and anode, and secondly, it depends on the electrolyte used in the cell. So students, EMF of a cell depends on the material of cathode and anode, and it also depends on the electrolyte used in the cell. And secondly, the most important thing is EMF is independent of the shape of electrodes, the distance between the electrodes, and the amount of electrolyte in the cell. The students, the EMF does not depend on the shape and the distance between cathode and anode, and also it does not depend on the amount of electrolyte in the cell. Now, coming to our second topic for today, that is internal resistance of a cell. Students, internal resistance is denoted by a small r, while external resistance is denoted by capital R, as we have done in exercise 8A. Here, the internal resistance is denoted by small r. Now let us study its definition. So, the resistance offered by the electrolyte inside the cell, the resistance offered by the electrolyte inside the cell to the flow of electric current is called its internal resistance. It is denoted by a symbol of small r, and its SI unit is ohms. The internal resistance of a cell depends on the following factors. So students, the internal resistance of a cell depends on 4 factors, and firstly, the first factor is the surface area of the electrodes. Internal resistance is inversely proportional to the surface area of electrodes. That is, larger the surface area of the electrodes, less is the internal resistance. And secondly, the distance between the electrodes. More is the distance between the electrodes, greater is the internal resistance. Thirdly, the nature and concentration of the electrolyte. Less ionic the electrolyte, or you can say higher the concentration of the electrolyte, greater is the internal resistance. Fourth factor is the temperature of the electrolyte. Higher the temperature of the electrolyte, less is the internal resistance. That means internal resistance is inversely proportional to temperature. So students, earlier we have studied that external resistance capital R is directly proportional to temperature of the conductor. But here, internal resistance is inversely proportional to temperature of the electrolyte. So just remember this factor and do not confuse internal resistance with external resistance. And now let us study the next very interesting topic, that is combination of resistors. Students, here we will be combining the external resistance in 2 ways. First way will be in series and the second way will be in parallel. So let us study one by one. So firstly, we will study about combination of resistors in series. So in figure 1, I have drawn an electric circuit having a battery and a closed key, and there are 3 resistors combined with a single wire. And students, as we have already studied in class 8th and 9th, that when the key is closed, electric current flows from positive end of the terminal to negative end of the terminal. So in figure 1, the direction of electric current has been marked with arrows, and I amount of current is flowing through electric circuit. So students, in series combination, the resistors are joined one after other such that same current flows through each resistors when key is closed. Here electric current flows same, that is same amount of electric current is flowing through all the resistors joined in series, but the potential gets divided. All the 3 resistors will not get whole of the potential, while the potential will be divided amongst the 3 resistors, that is V1, V2 and V3. So now the net resistance of series combination is sum of all the resistances. So students, in figure 1, the net resistance or the equivalent resistance RS stands for resistance in series. So the equivalent resistance for series is RS is equal to R1 plus R2 plus R3. Students, note that the equivalent resistance of series combination is always greater than the highest value of resistance joined in electric circuit. Now, for example, in the first figure, if you take R1 as 1 ohm, R2 as 2 ohms, and R3 as 3 ohms. So the highest resistance is of R3. And if you want to find equivalent resistance, that will be 1 plus 2 plus 3. That comes out to be 6 ohms. So it means that the equivalent resistance is greater than the maximum value of the resistance given in the circuit. Now students, our second type of combination of resistors is a parallel connection. So as you can see in figure number 2, the three resistors R1, R2 and R3 are connected in parallel form. If you can see from point A, I have taken three different ways in which current is reaching to the resistors R1, R2 and R3. These three ways are done by using three different wires. In series connection, we were having a single wire and thus current was having only one way to flow. While in parallel connection, we are having three different wires and thus when the current reaches point A, it has three different ways to flow. So, the current in the case of parallel connection will have different values for different resistance. So, students, in the case of parallel combination of resistors, the current I drawn from the battery divides itself such that different current flows in different branches of wire and the equivalent resistance for parallel combination is given by 1 divided by Rp, where Rp stands for resistance in parallel connection. So 1 by Rp is equal to 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. So students, kindly note that in parallel combination, the equivalent resistance Rp is less than even the smallest resistance connected. So students, here you take R1 as 1 ohm, R2 as 2 ohm, R3 as 3 ohm. Take R3 as 3 ohm and then find 1 by Rp, that will be equal to 1 by 1 plus 1 by 2 plus 1 by 3. And then take LCM, that will be 6 in this case. So R1 by Rp will be equal to 1 by 1 plus 1 by 2 plus 1 by 3. So if we take the LCM as 6, so the upper numerator will come 6 plus 3 plus 2 and 1 by Rp will be equal to 11 upon 6. Now student, this is 1 by Rp. So what will be Rp? Taking reciprocal on both sides, Rp will be equal to 6 divided by 11. And if you calculate it, 6 by 11 comes to be 0.545 ohms. Here I have calculated till 3 decimal places. Otherwise, it is a recurring decimal, 0.54 recurring decimal. Students, note that you are not supposed to keep the answer till fractions. We always have to find answer up to 3 decimal places. So Rp in this case is 0.545 ohms, while the minimum value, the smallest value of the resistance was 1 ohm. Okay, so we were having 1 ohm, 2 ohm and 3 ohm resistors connected in parallel such that the combined parallel combination resistor comes out to be 0.545 ohms. I hope this much is clear. The second point which you have to keep in your mind is the potential difference across each resistor is same. Students, in series combination, the potential difference were different. They were V1, V2 and V3. Potential was getting divided. But in parallel combination, all the resistors will get the same amount of potential. All the resistors combined in parallel connection will get same amount of potential difference. So students, if there are n number of resistors, then for series combination, we will take sum of all the resistors, all the n resistors, that is R1 plus R2 plus R3 plus R4, so on to Rn plus Rn. And for parallel combination, we will take reciprocal of resistances and then we'll take the sum of those resistance. So students, for parallel combination, it will be 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus so on to 1 by Rn. Now students, let us learn this combination of resistors by solving some numericals. So students, in figure number 3, 3 resistors of 6 ohms, 3 ohms and 2 ohms are connected together. Find the equivalent resistance of the electric circuit. So here, if you can see in figure number 3, students, 3 and 2 ohm resistors are in parallel, while 6 ohm resistor is joined in series, and it is joined in series to the combination of 3 and 2 ohms. Students, in such case, first of all, simplify the combination of 3 and 2 ohms such that we get an answer of 1.2 ohms. You can solve it using formula of parallel combination, that is 1 by Rp plus 1 by 1 by Rp is equal to 1 by 3 plus 1 by 2 is equal to 5 by 6, and then you take reciprocal. So Rp will be 6 by 5 ohms, which is equal to 1.2 ohms. Now student, this 3 and 2 ohms combination can be replaced by 1.2 ohms. So it means that basically we are having a 6 ohms resistance which is connected to a resistance of 1.2 ohms. So what we have done? We have simplified this 3 by 2, 3 ohms and 2 ohms resistance into 1.2 ohm resistance. So now this complete circuit will be having a 6 ohm resistor combined with a 1.2 ohms resistor, and both can be seen in series. So the total equivalent resistance will be, it will be 6 plus 1.2, that comes out to be 7.2 ohms. Now students, our second question is, find the equivalent resistance of the circuit shown in figure number 4 and 5. Now see figure number 4. Here the upper arm 5 and 3 ohm are connected in series. See, they are connected in one wire only, while there are two parts, upper and lower. So students, what to do? Can we take this series combination first and find its value to be 8 ohms? Then this combination of two resistance can be replaced by 8 ohms. That means that if I am having 4 ohms in lower arm, so I'm having a total of 8 ohms in the upper arm. So this 8 ohms and 4 ohms are connected in parallel to each other. So then you apply the formula of parallel resistances. That comes out to be 3 by 8, which to find Rp, we have to take reciprocal, and the answer will be 8 by 3 ohms, which comes out to be 2.67 ohms approximately. So this was your figure number 4. Coming to figure number 5, this is your figure number 5, as you can see here. Students, here also see, these are in one wire, while this here you need another wire. So see, if the current comes here, it will get divided into two wires. Let it be I1 and I2. And on reaching point R, whole of I2 will come in this wire. So both 4 ohms and 6 ohms are having same current, while 2 ohms is having a different value of current. So what does it mean? It means that these two are in series, while this is in parallel to the combination of series. It is also like figure number 4 only, but then it is like this: 4 ohm, 6 ohm. They are in series, while 2 ohm is in parallel to 4 and 6 ohms. So students, that means first we solve this triangular part, the arms of the triangular. So we'll get series resistance as 10 ohms, while in case of parallel resistance, what to do now? This 10 ohms and 2 ohms will be in parallel to each other. This will be 10 ohms and this will be 2 ohms. So your answer for that case will be 1.67 ohms. So now students, you can pause this audio and video and solve numerical number 13, 16, 17 and 19 in your physics notebook. And after you have tried the numericals as given on page number 202 of your physics textbook, you can further resume this interactive session to check your answer.